Okie dokie. So I'm in a new Java project here, and what I'm going to do is, well, basically we're going to be implementing a basic random genetic algorithm. Um, and as I go, I'll kind of figure out which direction I want to take it, but we're going to start off with some simple stuff. Um, if I could click. There we go. Like a main class. We're not going to extend anything yet. And what I want to do is establish a basic unit, which is going to be whatever our genetic module is. I don't know yet. We're going to find out. So we're going to call this world, and our player, per se, is going to be called a unit. And a unit's going to have a set of genes. So we're going to make a gene class, and basically what I want them to do is I want them to move. So a gene is going to indicate a movement, whether it be up, down, left, or right. So what I'm implementing is two things. It's going to be a constructor, which takes in two parameters of your x and y, and it's going to be getters and setters in here. And honestly speaking, my plans are only going to be allowing for one of these to be a number and the other one's going to be 0, so it's only going to be a change in left or right or up and down. A gene cannot modify both. We'll implement that logic as we get further into it. So the unit is going to be a list of genes. So we're going to call this a gene set. It's going to be a list, which is modifiable, and we're going to make a constructor for this unit that is pretty much empty for now. So now, what I have is I have a list of genes, or I have, this is my gene class, the list of genes, the base unit, and that's it, and an empty main class. What I want to do is I want to be able to create a random gene. So we're going to make a public static gene, random gene here, and basically what this is static means it can be accessed from any context, so I don't need to call new gene to get random gene. So I can just do gene.randomGene. So what this is going to do is we need to have an x and a y, and it's got to return a new gene x comma y. So right now this is only going to return 0. So we need to decide, are we changing the x or are we changing the y? And the way I'm going to do that is I'm going to just do some math.random functions. If you don't know, math.random returns a number between 0 and 1. 1 is non-inclusive. So where we're going to go from here is, first we need to decide if it's x or y. So if math.random is less than 0.5, we're going to change the x, and this will be the y. So x equals math.random. Okay, so now we need to decide the step size. How far do we want them moving with every random movement? So I'm going to say 1. 1 in either direction, either -1 or +1 for this one. So what we're going to do is we're going to do x equals math.random less than 0.5. It's going to be -1. And if that's not true, it's going to be +1. This basically means, it's basically a simplified if statement. So we're going to apply that same logic down here for the y. So that should be that. This should be our random genes now. So let's go back to the unit. And basically we need to create a list of units in our main class. And this is going to be basically our generation. And the way I'm going to do this is I'm going to increase each generation. Basically, I'm going to give them access to a new gene. I'm going to give them a new random gene, and then I'm going to breed the two highest performing units in that generation, use their base gene set as the new units. It'll make sense after I do a little bit of it. So what this does is basically Actually, let me get the basic reproduction done before I explain this. Um, Okay, so basically I just made a method that adds a random gene at the end of the gene set. Again, the genes are a list of actions that are going to be performed on the unit. While I'm at it, private int x equals 0, private int y equals 0. This is going to be their starting point each time. And basically reproduce is going to take the gene set of another unit and merge them with this unit. So what we want to do here is we want to take the gene set of this one and merge it with the gene set of that one. We're not adding them together, but we're going to average each individual gene. So for that to happen, we need a way to get a gene set. And why not the x and y, just for future. So we're going to loop through, we're going to create our new list here of our future genes. And what we're going to do is we're going to loop through this unit's genes. Okay, so this for loop will give us every gene in this gene set, and now that we've done that, actually speaking here, so this is the same thing, except now I have an index of it, so I can do that same thing for the other unit that we're reproducing with. Get gene set get I. So now we have the gene in the same location in their gene sets, and what I'm going to do is I'm going to average them. So gene new gene equals new gene gene 1 dot get x plus gene 2 dot get x, and then gene 1 dot get y plus gene 2 dot get y. So this is just the totals now. I want to average them. So what I'm going to do is I'm going to do new gene dot set x, new gene dot get x divided by 2.0, and we'll cast this whole thing to an integer. New gene dot set y, set y. Okay, so this is going to get added to our new list of genes up here. This is going to be the gene set for the next generation before we add the random gene to them. So genes.add new gene, and at the end of this we have a list of genes that are the average between the first set and the second set. So what we can do is we can return a new unit that has these genes. And this will be the base model for future generations. So now what we're going to need to do is we're going to need a way to clone this, clone any unit just in general, and you'll see why in a second. So what I'm going to do is I'm going to do public unit clone, and this is going to return a new unit of geneset.clone. Or that's not a method. Should be. Arrays as list, and then we'll do geneset dot to array. I'm going to cast this to a list of gene. Of course. There we go. Okay. So what this does is this will give us a clone of the gene set in a new object, so nothing will be the same. So we're going to go back to main here, and we need a way to perform the set of genes on our current location. So we're going to call this tick, and what tick is going to do is it's going to step through each gene. But let's have an integer of current gene location, and we're going to set that to 0. So each tick we're going to increase current gene location, and if current gene, at the beginning of it, if current gene location is less than the gene set's length, as in we're not going over the amount of genes that we have, we're going to get the gene that we're at, right? And we're going to gene set dot get current gene location, and with this we're going to modify our X and Y location every time. So once this is all done, I'm going to basically toss a boolean in here, is complete. This is going to return if current is greater than gene set.size. So basically we'll be able to call is complete to check if a unit's performed all the actions that it has. So let's go back here, and what we're going to do is we're going to do generations. List gene base gene set equals new array list, and let's just run it, I don't know, 10 times. What we're going to do here is going to create, let's also make an int generation, final int generation size, let's set it to 100. What we're going to do is we're going to for int I equals 0, I is less than generation size, I plus plus. Going to make a new unit, and in this unit we're going to call base gene set, so you'll see why I do this in a second. And we're going to do add units.add and this new unit. So from there, while units.get 0 is complete. So while it's not complete iterating through its genes, we're going to for unit u units u.tick. So what this does is this goes through every one of them and makes its next step. But before I do that, I want to add a random gene to all of these units. So each time they'll be getting a new random gene. So after it's complete performing all of its actions, we want to determine who is the best fit unit, or I guess who's the top 2 best fit units. And unfortunately, I cannot recall how to do that off the top of my head. So what we're going to do is I'm going to pull up the old Google over here. We're going to do Java sort by object field. Check this bad boy out. We honestly might be able to I see. This is what we want. But where does it come in better? Okay, so this bit of code here comes from, it's basically, it's a Java thing. So what I gather from this is we can compare, we do like that. What are you yelling at me for? Oh, I'm gonna finish this down here before it. We'll take it. Okay, perfect. So u1 dot fitness minus u2 dot fitness. Okay, so what we need now is we need a fitness function. We need to determine how fit a unit is, how good they are, how well they perform the task we want them to perform. So what I got here is I got a fitness function, and this is going to return 0 for a second, because I got to pop back over into here and basically convert them to ints. Okay. So it comes to the point now where we have to determine what the task of this generational thing is, the genetic algorithm. And what we're going to do with that is probably something along the lines of optimization. A genetic algorithm in itself is optimization, but the specific problem that I'm going to want to solve, you know, why don't we Google it? Let's Google some real-world optimization problems. I'll come back when I find one. Okay, so we're back. I got this idea, and it's basically, we're going to be training these units to not touch the middle of my screen. How you're doing that? Well, we're going to find out. But, basically speaking, what we're going to do is, we need a list of every location that this unit has been. We're going to call it a history. And it's going to be an array list of each point, which is just an XY coordinate. So each tick, every time we move this object, what we're going to do is we're going to do history.add new point x, y. And this is going to allow us to keep a track of pretty much every spot that it's been. So the fitness function, what it's going to do here is going to determine basically the fitness. So for point P history, so this is going to loop through every point, and we want to find out, let's say, okay, we're going to keep the screen to 750 by 750. So the dimensions are going to be 750 by 750. And we want to make sure that they don't cross the middle of that. So let me just make a quick. Okay. So if capital X on, if p.x is greater than bounds.getWidth divided by 2. So if they go to the right of that, then we're just going to kill them, right? We're going to say their fitness is -1,000. And if they never crossed it in their entire history, then we let them, you know, greater or equal them. They're not even allowed to touch it. If they never cross it, we're going to give them a fitness of 1, which means in this case scenario here, the most fit units are going to be 1, and there's pretty much no in-between. In a lot of cases, it would be distance, so like the distance they are to it. I could do that, but then they all just run off the screen the other direction forever. So we don't want to do that. We basically just want to let them wander in circles aimlessly for as long as possible. So we have our fitness function here. So it's gonna be 1. So 1 is 0. Actually, no. Okay, cool. So now index 0 and 1 are gonna be what we're breeding to get the best movements. Alright, I'm seeing an issue here. These need to be doubles. Where's the issue? There's an error in here. There it is. Okay. So yeah, okay, that'll work. Okay, quick change to the gene class, converted it to doubles. The unit class, I just got rid of the integer casting here for the reproduction. And basically, I forgot that I also want to keep it from going off the left of the screen, going out the top, and going out the bottom. So that's pretty easy. So if it's less than 0, they're dead. If the y is less than 0, they're dead. If the y is greater than the height, my bad, bounds.getHeight, then they're dead. It's pretty much they're gonna be stuck in half the screen. You can't see me touching the screen right now, but it's gonna be half the screen. I'm really hungry, not gonna lie. Let's move on. So this is almost a completed unit class. We just need to do unit reproduction here. So what we're going to do is we're going to do list gene. Actually, we could do it like this. Base gene set equals units.get 0 dot reproduce with units.get 1 and .get gene set. And that should do it for the algorithm. So I'm just going to run it real quick and just see what it does, because I don't remember what else I have to do. So let's print out something so I can tell you where the number 1 unit is. Okay, well, that can't be right. It looks like what they're doing here is just ridiculous, honestly. You know, I might be sorting this backwards, so it might be U2 minus U1. And that might yield a better result. Yeah, that yields a better result. The X should not be less than 0, though. Oh, you know what I could do? I could do acceptable here. Acceptable bounds.getWidth divided by 2 bounds.getHeight. Set that to an int. Set that to an int. And I could basically do if acceptable contains point. Okay, so that should be fine. if it doesn't contain point is where we have an issue. Let's run that and just see what happens. Okay, so by the end of it, I just did a quick test. I fixed the sorting. This is a line that just sorts it. So by running it, they should never, ever, ever cross that. Will go less than 0 on the x-axis, greater than 750 on the x, greater than actually, what is it? For, 3,500, 350 on the x. And y should never be greater than 750. So basically, they'll just keep reproducing and mixing their genes, and their genes are just the set of instructions that keeps them within it. So let's see. Okay, we're going to ignore some of those issues for now. I don't think I'm using a diverse enough gene pool here. We'll talk more about it later.